Let's take a look at problem 11.1.19, where we're going to compare two proportions and run a hypothesis test after we have two samples. And so in this case, a sample was done in 1942 of 1,100 adults, and 418 said they do not drink. They're abstainers from alcohol. That means they don't drink. And then a recent survey asked 1,100 adults, and you get 363. Now these are samples, and so what proportion of those said that they would abstain? Well, you're going to take 418 divided by 1100 and you get 0.38, and then 363 divided by 1100 and you get 0.33. So there is a difference in those two samples, but those are samples. Those are representative of the population, and so because they're not whole from the whole population, we don't know exactly if the populations are different. And the way we check to see if populations are different is we're going to run a hypothesis test comparing two proportions. And before you can do that, you have to verify the model requirements. And so these are the requirements that we either can assume or are true based on the data we have here. N and P again are the sample size and then the proportions you have. And so from there, then we would determine the null hypothesis. Here we're saying that the proportions from those two different years are equal, and the alternative in this case is here is that that they're not equal. And so I'm trying to see where in this question, has the proportion changed, meaning it's not equal, it's different. And so you're going to get a test statistic and a p-value. In order to do that, again, I recommend StatCrunch, so we would open StatCrunch to do that. Once you get StatCrunch, we are going to do proportion stats. I need those numbers there. So stat, proportion stats to sample, and we have summary data. And so we know for the first case it's 418 over 1100, and in the second case we have 363 sample over 1100. And then we're going to run a hypothesis test, check to see that's not equal, and then you compute. And then you get your test statistic and your p-value. And since the p-value is less than our alpha, which is somewhere here, what do we have here? Our alpha level of 0.5. We're going to test it against that there. There it is, level of significance. Since it's less, we reject the null hypothesis, which then we conclude then that there is a difference in those proportions. And so that's where we would have that. Now, where do we get this out of 100? And that since the p-value is 0.01, that's like a 1%, 1 out of 100, would we observe this type of data if the null hypothesis was true? And so that would happen 1 out of 100 times. Because that's so low, we reject the null hypothesis. And so we say there's sufficient evidence to support the claim that those proportions are different. It has changed.